We're on module 7 now. This is measurement demo form is where you got to click and you got to fill this out as we go along. So let me just go back to that form. Here it is right here. And what I want you to do is I want you to tell me what the measurement, I've got a piece of paper here. Just a regular old piece of paper, nothing fancy. It's got some writing on it, no big deal. But what I want to do is I want to measure this piece of paper, but using a bunch of different tools as my measurement tool. So the first one that we're going to use is we are going to measure using this tool right here. Now I'm going to try to back up so you can see this a little bit better. This is a meter stick, but it has no marks on it. It's just 1 meter long. Here's the entire meter stick right there. And notice that on this side, there are no marks. All we know is that this is 0 meters here, and this is 1 meter right over here. That's all we know. And what I want to do is I want to measure this piece of paper with this meter stick with no marks. So that's a question. What is your ability to measure with a meter stick that has, really it's got 2 marks on it. It's got 1 over here. This is 1 meter right there. It's also got 1 mark over here. This is 0 meters. It has a mark every meter. So what I want you to do is where it says, using the ruler which has marks at 0 meters and 1 meters, that means the smallest increment, the marked increment on this thing is 1 meters. It's got a mark here, it's got a mark here. Those 2 marks are a meter apart. With a ruler that has 1 meter increments, estimate the width of the piece of paper in meters. So here we go. Here's my whole, I'll hold this way back up here. Here's the whole meter stick. What is the width of this piece of paper right there? So here's the 0 end. I'm holding it up there. Go ahead and write in meters how wide this paper is from your view right there. There we go. Module 7, measurement in sig figs. You just click on intro to sig measurement in sig figs, and it's this first measurement demo form. All right. So we are getting some good answers in here. I've got an answer of 0.2. I've got an answer of 0.25, 0.15. You guys, let me ask you this. Here is, we have no marks on this meter. Someone's telling me they think they know it's 0.15. Here's the issue though. We don't even know where 0.1 is. Where is 0.1? We don't even know. So I'm gonna share this screen so you guys can see the summary here. Somebody said 0.5, somebody said 0.3, somebody said 0.25, 0.25, 0.2, 0.2, 0.2, 0.20, which is actually something different, 0.15 and 0.15. You guys, this is the important part here. We are not even agreeing to the tenths place. Some people say 0.5, some people say 0.3, some people say 0.2, some people say 0.1. You guys, we are disagreeing in the tenths place. That means that you cannot say, oh, it's 0.15. We're not even sure it's 0.1. You can't say it's 0.20. We're not even sure it's 0.2. You can't say 0.25. We're not even sure if it's 0.2 or 0.3 or 0.1. You can't have an additional uncertain digit. You guys, we can only estimate to the first uncertain one. And according to these results, the tenths place is uncertain. Do you guys see that? See how many people are disagreeing in the tenths place? And our goal is we all want to agree to how many places we go. I don't want you to go beyond what you think you can reasonably guess. As we can see on the last one with no mark, there's no marks on this ruler except for the ends, we can only reasonably guess to the tenths place. So if the distance between the marks, also called the smallest increment, is 1 meter, then we can reasonably guess to the nearest 0.1 meter, or a tenth of a meter. This ruler has got marks every tenths place. So the question is, what is the width of this piece of paper again? But now we have what's called a little more precision. We've got marks every tenth. This is 0 tenths, 1 tenth, 2 tenths, 3 tenths, and 4 tenths. But what I want you to do now is make a new estimate based on these. You either edit your response or add another response. This is for question 2. When we have marks every tenth of a meter like this meter stick does, Oops, sorry, let me line that up a bit better. Okay. What can we say about this measurement? I want you to estimate to the best that you possibly can using this tool right here. And I'll just show you the ruler again. This is 0.1 meters, 0.2 meters. And the question is, how big is this piece of paper from the perspective of this ruler? Right there, I'll show you right up there. Okay, there we go. How much is that? At this right end is 0.1, in the middle there is 1/10. 2/10 is right there, so it's obviously greater than what? Somebody go ahead and yell it out. It's greater than what? Very clearly here.
Than 2/10.
It's greater than 2/10, but how much greater? This whole thing over here is 1/10, so it's going to be 0.2, and then you guys can estimate this last decimal place. This is 0.0, this is 0.1, 0.2. It looks like a little bit over that, so go ahead and put your answer in there, and then we'll see what people say. Okay, so far we've got 11 responses. Okay, now you guys, for 0.2, someone said 0.20. Turns out that would be marked correct. However, you can get better. Can you guys see that that's greater than 0.2? Hopefully you can see that there's a big chunk over the 0.2 line there. So it's going to be greater than 0.2. It's got to be 0.2 something. We are actually all in agreement, except for we have one person that doesn't agree with us. We are all saying, yeah, it's 0.2 something, 0.23 here. We're saying 0.2 something, 0.22, we're agreeing on that. 0.22, another agreement. 0.21, we're saying it's 0.2 something. 0.2, we can do better than that. We can see it's greater than 0.2 by a little bit. You can see it's more than that. It ended up right here. So it's over 0.2. So that one actually wouldn't be called precise enough. 0.200 is actually telling us something that we don't know. You see how we're not even sure if it's 0.21, 0.22, 0.23? You can't say 0.200. That means that you're certain about the zero and you're only uncertain about the last zero. 0.20 I would actually accept, even though I don't agree with it. It is saying that we know it up to this hundredths place. Let's do one more. You guys, I've got this one right here. Now this is a meter stick that is marked off in centimeters. There's only centimeter marks on here. Each one of those is 1/100th of a meter. So I'm going to do this game one more time. I've got this end of the paper on the very edge of the ruler, and I'll show you where this line right here is 20 centimeters, or 0.2 meters is right there. That is 0.21 meters. This is 0.22 meters, but you guys can see it's between 0.21 and 0.22. What do you get for that? Go ahead and put in your results in box 3. I'll try to show it really close. There, as close as I can get. 0.20 is that one, the 20 centimeter mark is 0.20. The next line is 0.21. The next line is 0.22, but it's not quite 0.22. What are you getting? Go ahead and vote on that one. Let's see what we get. All right, and going to the responses. All right, now we are starting to get there. We are all in agreement, except for a couple of people that may need some more help doing this, and that's okay. This is maybe the first time actually measuring with precision for many of you guys. Notice that we've got 0.219, 0.219, 0.218, 0.217, 0.215, 0.21. This one I don't agree with because you're saying it's closer to 0.21 than to 0.22. Let's take one more look at this. Notice that it's greater than 0.2. It's greater than 0.21. You can't see 0.210. That's definitely not right. It's 0.21 something. And some people have said 0.218, 0.219. Those would all be good. 0.217 I would take. 0.2 I can't take. That's too far away. You're saying it's 0.200. So you're saying you know it to the thousandth place. But you can see that you are disagreeing with everybody else to the hundredths place. So this one actually wouldn't be acceptable. We're going to get a lot more practice. All the ones in the middle would be acceptable, and this one, all these would as well. So all these would be acceptable except for 0.200. We'll see why that is.